Hello guys, welcome back to my channels. So today I'm going to talk about VSEPR theory. Okay, valence shell electron pairs repulsion theory. So in this theory, I will talk about the uh, shape and geometry of the molecules. So let's start. So this theory predict the 3D shape of the molecules, and this shape is explained by the electrons pair and valence shells that present in central atom that minimize the repulsions of between the bond pairs and lone pairs. Okay, now discuss the geometry of covalent molecules. Okay, so before we start, I would like to discuss. So now we talked about those molecules have no lone pairs of electron in central atom. Only the covalent bond is formed. So now discuss first AB two types of molecules. So geometry is linear. Actually, I am talking about general forms. Okay. So, AB2 types of molecules, the geometry is linear and hybridization is sp hybridization. The bond angle between two bonds is 180 degree. AB three types of planar trigonal geometry with sp2 hybridization and bond angle is 120 degree is bond angle between two bonds. Okay. AB4 types molecule shows the tetrahedral geometry with sp3 hybridization and bond angle is 109.5 degree. Okay, so now discuss the AB AB5 types molecules, that is geometry will be trigonal bipyramidal with sp3 dehybridization. And AB six types of molecules shows octahedral geometry. The hybridization is sp3d2 and AB seven types of molecules shows pentagonal bipyramidal geometry and hybridization sp3d3. Now I'll talk about the geometry, regular and irregular. First I will discuss the regular geometry. Those molecules who has no hybrid orbitals that containing lone pairs in the valence cells central atom but only contains shared pair of electrons and so no distortions of the shape. That means the regular geometry those molecules shows who has no lone pairs of electrons. Okay, and there will be no change of shapes. But irregular geometry means central atom contains one or more than one lone, lone pairs of electrons in the valence shell. And geometry of the molecule is distorted to some extent because the repulsion interaction between lone pairs is happened and other lone pairs, bond pairs repulsion taking place. Due to this, the geometry will show irregular. Okay. Now we'll talk about, here is the most important point, order. The repulsion. The repulsions of lone pair is higher than that of lone pair bond pair, and least is bond pair. As you can see, these examples have one lone pair, so repulsion is taking place from lone pair to bond pairs. Okay, so because the presence of lone pairs, it will affect the bond angle as well as geometry. Okay, now discuss the geometry of the molecule, those containing only bond pairs of electron, no lone pairs. So first, I would like to discuss beryllium fluoride. So here we'll see the configuration of beryllium. So, so this is the configuration of beryllium 1s2, 2s2. Okay. So the valence electron is 4. So now fill the orbitals 1s, 2s, 2p orbital in ground state. So 1 is filled 2 orbitals and 2s is filled 2 orbital, and in excited state this electron will goes to the 2p orbitals. Okay. So therefore this one electron will share one electron with fluorine, okay, and form beryllium fluoride, two bonds, and hybridization is sp hybridization. And these kinds of molecules shows similar types of features and geometry. So here the geometry is, for this case, is linear geometry, and bond is covalent bond, and bond angle is 180 degree. Now discuss the another example, BF3. Okay. So BF3, the electronic configuration is 1s2, 2s2, 2p1. So valence electron is here 3. Okay. 3 is the valence electrons. Uh, so this is the ground state similar as I discussed earlier. Okay. Because here the 3 bond formation taking place, covalent bond form. So only one electron is uh, uh, unpaired electron. So we have to 3 unpaired electron. So one electron goes to another p orbitals, two p orbitals. So three are here. Three uh, electrons are is unpaired electrons. So in other step, these three electrons will share the paired electron with fluoride ions. Okay, fluoride, and form the sp2 hybridizations. So similarly, these types of molecules show similar geometry. So here the geometry is trigonal planar because of uh, forming the share pair of covalent bond with between boron and fluoride, fluorine. So another example is methane. So electronic configuration is this, and the valence electrons here, four is the valence electron. So here is in ground state two electron is unpaired, but we have four electrons. So here in excited state four electron is unpaired because this one electron goes to is this last two p orbitals. So here four bond is formed by sharing four hydrogens. So hybridization is sp3, and geometry, as you can see, geometry is tetrahedral geometry with bond angle between two hydrogen is 109.5 degree, and these types of Cl4 SiF4 show similar kinds of geometry. Okay, now discuss the um, another example, PF5. The electronic configuration is this, and here the valence electron is how much? 5. 5 valence electron is present. So 3p 3 3p 3d. In ground state 3d orbital is vacant, and so uh, we need 5 unpaired electron for the formation of this PF5 geometry. So here is the 5 electron unpaired electron in satisfied, and one electron will share 5 electron with share form the bond with fluoride. Okay, so hybridization is sp3 for this case, and this 3d orbital is 3z square orbital. Okay, for this case. So geometry is trigonal bipyramidal. So these three bond, three fluoride ion, fluoride or fluorine ion in fluoride in triangular form, and one fluoride is axial bond, form the axial bond. Okay, so this axial bond formation is z square orbital. Okay, 3d z square orbital. So these kinds of structure so similar geometry. Another possibility also for this case is square pyramidal. It will it can be possible, okay, but less stable than this trigonal bipyramidal geometry. Okay, and here this for the square pyramidal, here the d is x square y square orbital involved. Okay, but this is less stable compared to this. Another example is SF6. So similar, the electronic configuration is this, and here the two electron is unpaired electron, so we need 5 electrons, unpaired electrons. So one electron goes to 3d, another from 3s electrons will goes to 3d. So here total is 5 unpaired electron is in excited state. So one electron will shared by this fluoride ion. Okay, and form the hybridization, and and here that this one is 3d square orbital, and this one is 3dx square y square orbital. So hybridization is sp3 and d2. So sp3 d2 orbitals. Okay. The geometry is for this case is octahedral geometry, or we can say the square bipyramidal geometry. Similarly, last example for this case, IF7. So configuration is this, and here single electron is unpaired electron. So we have we need seven unpaired electrons. So three paired three from the three paired electrons, and this will goes to 5d orbitals. Okay, then one electron is shared by this right ion form the covalent bond, and the hybridization is for this case is sp3d3, one three one 5s orbital and three p orbitals and three d orbital. So hybridization is sp3d, and here the involvement of d orbital is dxy dyz dzx. Okay, so geometry is pentagonal bipyramidal geometry. So now talk, uh, I will discuss the geometry, those compounds having bond pairs as well as lone pairs of electrons. Okay. So first I would like to start from SnCl2. So electronic configuration is 5s2 5p2. The valence electron is 4 because this belong to the carbon family uh, in group of the periodic table. So in ground state, this is the electronic configuration and filling of electrons. But here the two bond only, two chloride and formed. So two bond is formed. So two electron is enough for the pairing with chloride ion. Okay, so hybridization is sp2 hybridization, and the geometry for this case is V-shaped geometry. Okay, so similar for the ammonia. Ammonia having one lone pair electrons. So this will show pyramidal geometry. Uh, for this scale hybridization is sp3. And similarly, this hydronium ion. Hydronium ion show numbers of valence electron in central atom. At central atom is oxygen is 8. So hybridization is sp3. Geometry is pyramidal. For this case, hydrogen water molecules. So configuration is this, and the geometry is V-shaped geometry, and configuration hybridization is sp3. Okay, and for SF4 configuration is electronic configuration is this, and sp3d hybridization and geometry is irregular tetrahedral geometry. Similarly for ClF3 the configuration is this, and in last orbital one unpaired electron, so we need three bond formation. So three unpaired electron is required. So this one goes to this d orbitals. So three bond will shared pair electrons and two lone pairs of electrons. Okay. So hybridization in sp3 d, two is lone paired electron. So the geometry is for this case distorted because this repulsion lone pair repulsion is higher compared to lone pair bond pairs. So here the distorted geometry, T-shaped geometry. Okay. For this case, XCF2, the configuration is this. Here there is no unpaired electrons, so we have to we need two unpaired electron. So in excited state, the form the two unpaired electrons, and these two will share one with right hand, and the geometry and these lone pairs of electrons, as you can see here in this geometry. So the geometry is linear geometry for this case. Okay, and XEF F4, the electronic configuration is this, and the filling of electron in ground state is this. Similarly, for this case is also there is no unpaired of electron, so we need four unpaired electron. So these were from this orbital p orbital, two electron will goes to d orbitals. So uh, these four orbitals will share one more electron with fluoride ion, and the hybridization will form for this case is sp3d2. Okay, and the geometry for this case two lone pairs square plane geometry. And last example for this is IF5. The electronic configuration is this, and here one unpaired electrons. So we need five unpaired electron for this case. So five electron here shared paired electrons, and the hybridization is for this case sp3 d2. And structure is this square pyramidal structure. This lone pairs of electron is present in the axial position. So this is what I drawn the exam structure. This is a stable structure. Okay, so this is a square pyramidal structure. So I hope you understand. If you found this video interesting, so please do like and subscribe my channels and comment also. Okay, thank you for watching.